Welcome to FMSP Online Revision. This session is for AQA M1, topic is projectiles, and we're looking at question 7 of January 2011. So the question itself says that an arrow is fired from a point at a height of 1.5 metres above the horizontal ground. It has an initial velocity of 12 metres per second at an angle of 30 degrees above the horizontal. The arrow hits a target of 1 metre above the horizontal ground, so this is our target, and the path of the arrow is shown in the diagram, where we model the arrow as a particle. So 5 parts to the question. First of all, show that the time taken for the arrow to travel to the target is 1.30 seconds, correct to 3 significant figures. Secondly, find the horizontal distance between the point where the arrow is fired and the target. In part C, find the speed of the arrow when it hits the target. And D, find the angle between the velocity of the arrow and the horizontal when the arrow hits the target. And lastly, state one assumption that you have made about the forces acting on the arrow. So let's have a look, starting with part A. So it says, show that the time taken for the arrow to travel to the target is 1.30 seconds, correct to 3 significant figures. So remember, when you're doing these questions on projectiles, you have horizontal motion and you have vertical motion, and we need to consider these things very carefully. So horizontally, so we are projecting the arrow with a velocity of 12 meters per second at an angle of 30 degrees. So initially our velocity is 12 cos 30 horizontally, and that means vertically it's going to be 12 sine 30. Just make sure you get those correct. If we just concentrate on the vertical bit, let's assume if we're projecting it up in the air, that we're taking downwards will be negative and upwards will be positive, sorry I should say. So that's what we're doing. So upwards is positive. So when we have the acceleration, it's going to be negative 9.8. That also means if we're going upwards as positive, then S, the displacement, if we're landing, just be careful, we are landing at a 0.5 meters below where it was projected, then that's going to be negative 0.5. And what we're asked to do is to show that the time is 1.30, correct to 3 significant figures. So we're finding the time. So we're going to use S equals ut plus a half at squared. So that's the formula that we need. So that is the one that connects the information that we're given. So if we substitute that in, we have negative 0.5 equals 6t, because remember that the sine of 30 is a half, so 12 times a half is 6. So that's going to be 6t minus a half at squared, so a half of 9.8, so minus 4.9 t squared. So rearranging that, we'll bring that across to the left, so it becomes positive, and that's going to, the 6t will become negative, and then we have negative 0.5 already. So we're arranging it in the form ax squared plus bx plus c equals 0. It won't unfortunately factorise, so what we do need to do is use the quadratic formula. So t equals minus negative 6, so that's plus 6, plus or minus the square root of b squared, which will be 36, minus 4ac, so that's a minus, and that minus is going to give us a plus, so it's going to be 4 times 4.9 times 0.5. Let's just put that over, and then that's all over 2a, which is 9.8. So you're going to get two values for t, so it's going to be 6 plus or minus the square root of 45.8. If you simplify that under the square root, you'll get 45.8, That's all over 9.8, and that gives us two values. Now the two values are going to be either t equals 1.3028 or t equals a negative value. Now obviously a negative value is not going to be appropriate for our question, so that is not right. So what we've ended up with is t equals 1.30 to three significant figures, and we can just about get that in there. So that completes part A. In part B now we've got to find the horizontal distance. So we want to know what this distance is. But we do know that it was projected with a horizontal velocity of 12 cos 30, and we now have a value of t. So we can now use that value of t. So if we just look at that again, I'll write it out just to make sure we're okay. So u is equal to 12 cos 30, and t now is equal to 1.3028, and we'll take that slightly more accurate value. We won't round at this stage. So again, we could be using s equals ut plus a half at squared, but of course horizontally the acceleration is naught. So just remind ourselves that horizontally no forces acting, no acceleration. So that implies that s is equal to 12 cos 30 times 1.3028, and if you multiply that out it comes to 13.539, which we would write as 13.5 metres to three significant figures. And again, we'll just give our answers, as we always should do, to three significant figures. So effectively, as I say, we are just taking this answer for our time and we're moving it over here to use in our horizontal motion. So let's move on and have a little look at what parts C, D and E say. So in part C we're asked to find the speed of the arrow when it hits the target. So again, we have to be very careful because we have a horizontal velocity, and we have a vertical one. Now remember, horizontally it was 12 cos 30. Acceleration is naught, so that means that the velocity remains at 12 cos 30. But vertically it will change. So initially it was 12 sine 30, which we said was 6 because sine of 30 is a half. But we know that it travelled for a time of 1.3028. And we also know that the acceleration was negative 9.8 because we were taking upwards to be positive. So using v equals u plus at, we can find the vertical velocity v equals u, which will be 6, plus at, which will be minus 9.8 times 1.3028. And that turns out to be minus 6.7674 meters per second. Now I'm not going to round that because we now have the horizontal velocity and the vertical velocity, and we're asked to find the speed. So we are now, what we need to do is, this is 12 cos 30, and then we have this going downwards, which is 6.7674, and using Pythagoras' theorem now we can find the speed. So the speed is going to be equal to the square root of, just Pythagoras theorem, nothing more, the square root of 12 cos 30 all squared plus 6.7674 all squared. And that turns out to three significant figures to be 12.4 meters per second. So again, you just need to do that carefully, check, and I haven't put in the value of cos 30 because I would do all that on a calculator, and check that you get 12.4 meters per second. We're also asked in part D to find the angle between the velocity of the arrow and the horizontal. So if we call that angle alpha, so this was C, this is part D. So in part D, tan of alpha is going to be equal to opposite over adjacent, so 6.7674 divided by 12 cos 30. And that gives us, if we check that carefully, that gives us an angle of 33.1. So we have the speed, 12.4 meters per second, at an angle of 33.1 to the horizontal. And lastly, in part E, it says, state one assumption that you've made about the forces. So you could say either that there is no air resistance, which obviously implies that the only force acting is its weight. But if you prefer, you could say the only force acting is the weight. But the important thing is there is no other force. So if we have a look at the marks for that as we go through, just going back up to the beginning, there was a method mark for using S equals ut plus a half at squared and getting the terms correct, and then an accuracy mark, an accuracy mark for the terms and another accuracy mark for the signs. So there were two accuracy marks by the time you got to your quadratic here, 4.9t squared minus 6t minus 0.5. You then got a method mark here for using the quadratic formula, but it was dependent on your method mark up here, that you'd done this correctly, and then you got an accuracy mark for showing 1.30 seconds. So that was 5 marks for part A. There were 2 marks for part B, so basically S equals ut, there was a method mark there, and an accuracy mark for getting 13.5. And we move over to part C, 4 marks altogether for part C. So you got a method mark for using V equals U plus AT, and an accuracy mark if you did that all correctly. And you then got a method mark and an accuracy mark here for using Pythagoras theorem to find that the speed was 12.4 meters per second. So those were the 4 marks for that. There were then 2 marks for finding the angle, a method mark and an accuracy mark, and that accuracy mark was a follow-through mark. So if you made a mistake up here and didn't get your any of the parts, the vertical velocity correct or anything like that, then there was a follow-through mark. And then there was a B1 mark, a statement mark, no method, for saying either no air resistance or the only force acting is its weight. So don't forget that if you want to look at some other revision videos, then you can do so by going to the Further Maths Support Programme website and following the link to online revision.